Alright guys, so I'm going to walk you through number 7 here of the 2.5 homework. So number 7 and 8 are just, they're pretty tough problems, especially number 8. So I'm just going to walk you through both of these problems here. Actually, I'll make one video for 7. I'll make a separate one for 8 just in case somebody doesn't want to watch both. But anyway, so let's go ahead and begin. The first thing I would do is I would start by identifying what the u is on this problem. The u is 3 minus 2x. Okay, so how do I know that that's the u? Well, I don't really have a great answer for you other than the fact that I just know that's going to work. Because, I mean, this one here, you could try to make that the u and see what happens. You might be able to figure something out with making that the u instead. But they're both technically inside functions, so it's hard to tell. I'm curious now. I wonder if you could actually do that. But I'm going to go ahead and go with what I know works for now. We're going to say that u is equal to the 3 minus 2x. Okay, next we have du over dx is negative 2, and du over negative 2 is equal to dx. And so now if we go ahead and do our u substitution here, we're going to have x plus 7. And then we're going to have the cube root of, and instead of 3 minus 2x, we're going to have a u in there now. And instead of a dx, we're going to have a du over negative 2. All right. So the next thing we need to do is, as you can see, the x is still in there. The x did not get canceled out. So we need to do something about that. And that's where we go right back up here to our u equation, and we solve for the x. So I'm going to take this and rewrite it, and then I'm going to get the x by itself. So the first thing I would do is minus the 3 on both sides. And then I would divide both sides by a negative 2. If I divide both sides by a negative 2, we end up with negative u over 2 plus 3 over 2 equals x. Okay. So that being the case, then, we're going to go ahead and replace the x with that. Sorry, I'm working from home and there's loud people. Plus 7. So instead of x plus 7, now we have negative u over 2 plus 3 over 2 plus 7. Now we have all u's again, but it still doesn't look very friendly. But we're going to fix that up some more. All right, so first of all, I'm going to rewrite that as u to the 1/3 power, and then I'm going to put this underneath of that u to the 1/3 power. Get a negative there. And now I'm going to distribute this thing right here into the parentheses. So really not a whole lot different than the rest of the problems. It's just that I think it's a little bit uglier in terms of, dealing with radicals and all that stuff. But pretty similar to the rest of the problems. All right, so now here's one of our issues that we have to deal with. If I do u to the 1st power, and I multiply that by u to the 1/3, we would have to add the powers together if we do that multiplication. Because when you multiply two terms together, you add their exponents. So what's 1 plus 1/3? Well, it's actually going to be pretty much the same exact process we go through when we integrate. You're just going to 1 plus 1/3 is going to end up being 4/3. So, using the wrong mark. Right. So if I do u to the 1/3 times u to the first, I'm going to get u to the 4/3. And then if I do the bottom, 2 times 2, I get 4. Now notice that there's a negative here and a negative here. So when I multiply those, the negatives cancel and we're left with a positive. Now I'm going to multiply the fraction times the middle one. And so 3 times the 3 multiplied by the u to the third gives me 3u to the third. And then on the bottom we have 2 times 2 again, which is 4. But this time that's a positive being multiplied by a negative. And so that's actually going to make this whole thing become negative instead. And then we have the last one here. Once again, a positive times a negative is going to end up being negative. And we have 7u to the 1/3 over 2. Now I haven't integrated yet, so don't forget to put your integral symbol there. All right, so at least we've gotten it simplified. It doesn't really look very simple, but it's actually in a much simpler format now to be ready to integrate. So now we're going to go ahead and do our integration. That's where you add 1 to the power and you divide by that number. Okay, so I'm going to add 1 to the power. If I add 1 to that, I'm going to end up with 7/3. And then you divide by that power. Now, we've talked about this before. When you divide by a fraction, that's the same as multiplying by its reciprocal. So I'm going to multiply it by 3/4 instead. Same thing for the next part. We're going to add 1 to the power. It's going to become 4/3. And then we're going to multiply by the reciprocal of the power. Last one, going to add 1 to the power. And then we multiply by the reciprocal. And we don't want to forget our plus c, of course. So now the integration is done. And now we just kind of get to clean this thing up a little bit so it's not so ugly looking. So first of all, multiply these straight across and you end up with 3u to the 7/3 over 16. Next, we end up with minus 9u to the 4/3 power over 16. Next, we have 21u to the 4/3 power over, looks like 8 plus c. All right, we're getting there. We're getting there. Now, something I want to draw your guys' attention to is that these two terms here, they both have a u to the 4/3 power. So those are like terms. We can actually combine those, but I can't combine them until they have a common denominator. So I'm going to give it a common denominator. I'm going to multiply the top and the bottom of this one by 2. So they have a common denominator of 16. Okay, now that I've got these two like terms with a common denominator, I can combine the numerators. Negative 9 combined with negative 42 gives me 51, negative 51. So let's write that out. And then, of course, our last step is to replace the u with the value that we know u to be. So u is 3 minus 2x. And that should be our final answer. That was a really nasty problem, but there you have it. So I'll leave it there, and then I'll move on to one for 8.